So starting from this week and probably for the next few weeks, we're going to be practicing geometry problems in the AMC 8. And I sent you guys ahead of time some practice problems for you guys to try in case the class is too fast. So let's just jump into it. And don't forget that if you have any questions, you can always private message Benjamin. Okay, here's the first problem. A square with integer side length is cut into 10 squares, all of which have integer side length, and at least 8 of which have area 1. What is the smallest possible value of the length of the side of the original square? Okay, so let's get started here. So the first thing that you're going to notice is that you have 10 squares, all of which have integer side length. So from there, you can immediately eliminate option A. And the reason for that is because with option A 3 by 3 square would only be able to cut into 9 squares, and the problem is asking for 10. So if you go one up and you try to do a 4 by 4 square, then they require that 8 squares have area 1, which means they have side length 1, and that means 2 of them have to have side length greater than 1. And you could try 2 squares having side lengths of 2 by 2. And it turns out that answer choice B actually works because you can have, for example, 1, 2, 3, 4, 5, 6, 7, and 8 squares with area 1. And you can have 1, 2 squares with area 4. And since they're asking for the smallest possible value, we know that we've got the correct answer because the smallest here that we haven't eliminated is B. Okay, so let's move on to the next problem. Two circles that share the same center have radii 10 meters and 20 meters. An aardvark runs along the path shown, starting at A and ending at K. How many meters does the aardvark run? Okay, let's get started here. So I'm just going to briefly trace the path that it's running. So the path starts here at A, and you go a quarter way around the bigger circle. Then you travel this distance. Then you go a quarter way around the smaller circle. Then you go through the diameter of the smaller circle. Then you go another quarter way around the smaller circle, and you travel to the outside circle again. So really this path has 6 stages. 1, 2, 3, 4, 5, 6. So the radii are 10 meters and 20 meters. So their difference is 10. So we immediately know that paths 2 and 6 have a length of 10. So this length here is 10, and this length here is 10. So now what we want to do is we want to figure out the length of path 1. So the radius of the smaller circle is 10 meters. So this distance is 10. And so the circumference of the entire big circle is 2 pi r, which is equal to 40 pi. But since we're only going a quarter of the way around, it's actually a fourth of that, which is 10 pi. So now we add the 10 from stage 2 right here. And now we have to go a quarter way around in step 3. So the radius of the smallest circle is 10, which means its circumference would be 2 times pi times 10 is equal to 20 pi. And a fourth of that would be 5 pi. And notice that actually stage 3 and stage 5 are actually the same distance. So we can just double that to become 10 pi. And then we're left with stage 4 in the middle here. And that's just the diameter of the smaller circle, which is 20. And finally, stage 6 here, which we've already calculated, is 10. So that should give you 20 pi plus 40, which is E. Okay, so let's go onward. Two angles of an isosceles triangle measure 70 degrees and x degrees. What is the sum of the 3 possible values of x? Okay, so we can start off this problem by considering different cases. So let's draw our isosceles triangle. Okay, so our first case is if our x degree angle is actually at the top here. So to clarify, these two sides are equal. So that would mean that this is 70, and this is 70, and this is x. Okay, so that means that x is equal to 180 minus 70 minus 70 is equal to 40 degrees. So that's the first case. Okay, so second case here is if, so we have our triangle here. So second case is if this is 70 and this is x, which means this is also x. So from here, we get that 2x plus 70 is equal to 180, which means 2x is equal to 110. So x is equal to 55 degrees. And our last case here is if $70 and x are actually the base angles of this isosceles triangle, which means that x would equal 70. And so then that means this angle would have to be 40 degrees in order for all of them to add up to 180 degrees. So in this case, x is equal to 70. So here we have three answers: 40 degrees, 55 degrees, and 70 degrees. And if you add them up, then you should get D, 165. Okay. Two congruent circles centered at points A and B each pass through the other circle's center. The line containing both A and B is extended to intersect the circles at points C and D. The circles intersect at 2 points, one of which is E. What is the degree measure of angle CED? Yeah, I'm not trying to actually talk. I'm just drawing the diagram ahead of time for you guys. So anyone else want to take a shot at this problem? You can try typing the answer to me privately in chat. Okay, so let's go ahead and get started. So I drew the diagram here, and the key realization is that you have to connect AE and EB. So it's kind of a bad diagram, but you'll realize that sides AB, EB, and AE are actually all equal to the common radius of the circles. So that means that triangle AEB is actually equilateral. So we know that right off the bat, this is 60 degrees. This is 60 degrees. And this is 60 degrees. So they're asking us for CED. So that means that we have to get angles CEA and angle DEB. And those two angles added to AEB, which is 60 degrees, will get the answer. So in triangle CAE, we know that CA is also equal to AE because they're both the radius, which means that this angle and this angle are equal. So by the exterior angle theorem, you know that those two angles add up to 60, which means that each is 30. So you know that this is 30 degrees. And if you use the same method, you'll find that on this side, BED is also 30 degrees. So if you add the angles together, 30 plus 60 plus 30 is equal to 120 degrees, which is C. So I know the diagram here is a little messy, but hopefully you guys can draw it better by hand on paper at home. Okay, so a straight 1 mile stretch of highway, 40 feet wide, is closed. Robert rides his bike on a path composed of semicircles as shown. If he rides at 5 miles per hour, how many hours will it take to cover the 1 mile stretch? Note that 1 mile is equal to 5280 feet. Okay, so let's get started. So they tell you that the highway is 40 feet wide, and you can assume that by 40 feet wide, they mean that this distance right here is 40 feet. Okay, so that means that this length right here, if you take the center of one of these semicircles all the way to the edge, that was not a straight line, all the way to the edge, then this distance here is 20 feet. So you can find uh, the perimeter of each of these semicircles by using the formula, so that you know the total perimeter would be pi times the diameter, which is 40, is equal to 40 pi. But since we're saying half of circles here, not the whole circle, then the total would actually only be 20 pi. So then the question now is, how many semicircles are in this 1 mile stretch that the problem is talking about? So they tell you that 1 mile is 5280 feet. So each of these semicircles takes up 40 feet. So what's 5280 divided by 40? Yep, that's 132. So now we know that there are actually 132 of these semicircles on the entire highway. And since for each of these semicircles the perimeter is 20 pi, and they're asking us if he rides at 5 miles per hour, how many hours will it take? Then we know that distance is equal to speed times time. And the distance here, the total perimeter covered would be 132 times 20 pi for each semicircle. The speed here would be 5 miles per hour. And keep in mind that we would actually have to convert 5 miles per hour to feet, because I believe all of our 20 pi here is actually in feet. So what we really need to do is convert 5 miles per hour to feet per hour. So there are 5280 feet in a mile, and there's 5 miles. So 5 times 5280 miles per hour is our speed. And then we would multiply by the time that we're trying to find. So when we try to solve this equation, can you guys tell me what the answer is? So right, when we solve this equation, we would get that t is equal to pi over 10 hours, which is B. Keep in mind, if you guys want to ask questions, don't forget to send them to Benjamin. Right, the answer is B. Okay, so let's move on to the next question. Where's the next question here? Okay, so this I believe is the next question. So a ball with diameter 4 inches starts at point A to roll along the track shown. The track is comprised of 3 semicircular arcs whose radii are R1 is equal to 100 inches, R2 is equal to 60 inches, and R3 is equal to 80 inches respectively. The ball always remains in contact with the track and does not slip. What is the distance the center of the ball travels over the course from A to B? So we seem to have 2 conflicting answers here. And spoiler alert, this problem is actually a trick question. So there's a very common answer here that you might get that's actually not the correct answer. Okay, so first of all, you might think that we can just, if we split this diagram into 3 different parts, R1, R2, and R3, then the perimeter of R1 would just be 100 pi, and the perimeter of R2 is just 60 pi, and the perimeter of R3 is just 80 pi. So that would give you 240 pi, which was B. But unfortunately, this is actually the incorrect answer, because if you look closely at the problem, they're asking the distance the center of the ball travels. So what we calculated, which was this distance here, tracing out exactly the semicircles, is actually the distance that this tip of the ball here travels. So the center of the ball is actually a different place, because they tell you that the ball has diameter of 4 inches. So from here, what you can actually do is pretty smart. So just by getting 240 pi and not doing any other calculation, I can actually get the answer. So if you think about it, we know that for the region of R1, the center of the ball is actually going to travel less than we think. Because if I trace out this track here, that track is actually less than the original semicircle. And similarly for R3, we're going to trace out a track like that, which is again less than the original semicircle. So for R1 and R3, the real values are always going to be less than 100 pi and 80 pi. And for R2, we're going to trace out that track, which is actually more than the 60 pi. But if you notice, we're actually losing a lot more distance from R1 and R3 then we're gaining from R2. So you could say that the actual answer has to be less than 240 pi. And so therefore the answer would have to be A, because that's the only choice that's less than B. So you could notice that, or you could just do the problem like normally without the answer choices. And if you do the problem normally, then let's just go back to our diagram. Then you would notice that, let's find this distance here, the distance from this semicircle center to the center of the ball. So the radius of the ball is 2 inches. So this radius is actually 2 less than the 100 that they told us, which would be 98. So our circumference here is 98 pi. And if we go back, let me just draw a ball here. If we go here, then the radius of R2 is actually 2 more than we would expect. And if you calculate, then this comes out to a circumference of 62 pi. And for R3, again, it's 2 less than 80. The reason we know it's 2 is because they tell us that the diameter is 4 inches, which means that the radius of the ball is 2 inches. So you would have to subtract 2 off of every semicircle. So for R3, we would get 78 pi. And if you add these together, then you should come out to 238 pi, which is A. Okay, next question. In the figure below, choose point D on BC so that triangle ACD and triangle ABD have equal perimeters. What is the area of triangle ABD? Sorry if it's a little loud on my side. It's actually raining over here. I do not live in Maryland. I live in central New Jersey, which happens to be under a heavy thunderstorm right now. Oh, that's a coincidence. We have a few people from California in this class. We have a lot of people from California. One person from Wisconsin. Okay, let's go back to the problem here. So, has anyone figured it out? So the key to solving this problem is that you have to set a variable. So let's just choose a point D here. Let's say we put it right here. So since these two triangles have equal perimeter, let's say that we call this x, which means that this length has to be 5 minus x. So in order for them to have equal perimeter, then the perimeter of one, which is 3 plus 5 minus x, plus whatever the length of AD is equal to the perimeter of the other, which is 4 plus x plus whatever AD is. So AD conveniently cancels out. So what you get if you rearrange is that 4 is equal to 2x, which means that x is equal to 2. So now we can erase the x's here, and we get that this is 2 and this is 3. So they're asking for the area of triangle ABD, which is this triangle here. So what you notice, if you kind of tilt your head around and imagine in these two triangles, you are considering this to be the base and this to be the base, then these two triangles have a base ratio of 2 to 3, but their height for both triangles is the same. So the area of the entire 3, 4, 5 triangle is 1/2 times 3 times 4 is equal to 6. And if you're trying to split the areas of the triangles into 2 to 3, then let's say that would mean that 2 times y, for example, plus 3 times y would equal to 6. So solving this, you would get y is equal to 6 over 5. And the area of triangle ABD, because its base has a length of 2, would be 2 times of y. So 2 times 6 over 5 is 12 over 5, which is d. Okay, so moving on. Marla has a large white cube that has an edge of 10 feet. She also has enough green paint to cover 300 square feet. Marla uses all the paint to create a white square centered on each face, surrounded by a green border. What is the area of one of the white squares in square feet? If it's actually too noisy for you guys on my side, I can try muting myself in between questions. Okay, so let me briefly explain what this problem is talking about. So it might seem a little wordy, so it's actually a three-dimensional problem. So Marla has a cube here. So here's my cube. And basically, she has enough green paint to cover 300 square feet. Each edge of this cube is 10 feet. And basically, let's just imagine one face of this cube. So she wants to create a white square centered on each face, surrounded by a green border. So remember that this cube is originally white. So all we really have to do is just paint the border of each face green. So imagine I'm taking my paint here and painting it like this, so that there's a white square in the middle of it. So basically that's what she wants to do to each face. And they're asking for the area of the square in the middle. Okay, so each face of this cube has an area of 10 times 10 equals 100. And basically to find the area of the white in the middle, you just have to subtract the green. So there's 300 square feet of green paint, but she's doing this on all 6 faces, which means that on each face she's going to use 300 divided by 6 is equal to 50 square feet of green paint, which means left over there's going to be 50 square feet of white square, which is D. So that was kind of a bit of an easy problem. Some people might have tried in the real test to maybe do some complicated calculations and try to find for example, the distance, the thickness of the green, and the side length of the white square, but you don't really need to do that. You just need to think about it in terms of areas. Just remember that the area of something can always be split into the sum of smaller areas. Okay, so next problem. A 1x2 rectangle is inscribed in a semicircle with the longer side on the diameter. What is the area of the semicircle? Okay, so they're saying that we have a 1x2 rectangle. So here's the diagram below. So here's a rectangle in brown, and the height here is 1, and the length here is 2. And since it's inscribed, that means that each corner of the rectangle is touching the edges of the semicircle. So half of the length here, which is 1, and we're told that the height is 1, 2. So basically we can find the radius of the semicircle by the Pythagorean theorem. So that means that our radius is square root of 2. So to find the area of a circle, this is pi r squared, and our r is square root of 2, so that's equal to 2 pi. But this isn't the full circle. This is actually a semicircle, which is half the circle. So half of 2 pi is equal to pi, which is c. The square root of 2 is here because this was actually taken from the solution key to this problem. Okay, so moving on. A square and a circle have the same area. What is the ratio of the side length of the square to the radius of the circle? So we're told that the square and circle have the same area. So let's say that the side length of the square is s. And let's say that the radius of the circle is r. So we're told that s squared is equal to pi r squared. So they're asking for s divided by r, which is the ratio. So let's divide both sides by r squared. So you'll get s over r in parentheses squared is equal to pi. So if you take the square root of both sides, you'll get that s over r is equal to square root of pi, which is b. So that was a pretty easy problem. I mean, it's 16. Okay, so moving on. The diagram shows an octagon consisting of 10 unit squares. The portion below PQ is a unit square in a triangle with base 5. If PQ bisects the area of the octagon, what is the ratio XQ over QY? So bisect means that this line in the middle here splits the area into two equal areas. So if the octagon, the weird looking octagon, is 10 unit squares in area, that means that on each side of this red line the area is 5 unit squares. So bisect basically means cut in half. So we're actually getting a lot of different answers. There's like 3 different answers that are being thrown around. Okay, there are a lot of different answers here. Okay, so let's start the problem. So they're asking for xq over qy. So this length over this length. So I know it might look like those two lengths are equal, but they're not because diagrams aren't necessarily drawn to scale. Okay, so we're told that if we draw this line everything on the lower side of it has an area of 5. So we already know that this square here has an area of 1 because it's a unit square. So that means that the area of this big triangle here is 4. So we can count that the base of this triangle is 1, 2, 3, 4, 5 units long. So let's say that the height of our triangle here is h. That would mean that 1/2 times 5 times h is equal to 4, which means that h is equal to 8/5 if we solve the equation. So h consists of qy here plus this unit length. So if we subtract the unit length of 1 away, then that means that qy is equal to 8/5 minus 1 is equal to 3/5. So if this length here is 3/5, then that means that xq is equal to 1 minus 3/5, which is 2/5. So they're asking us for xq over qy, so here's your xq, here's your qy, and if you divide them, you get 2/3, which is d. Okay, so it looks like we have time for one more question. So let's do this one. In the non-convex quadrilateral ABCD shown below, angle BCD is a right angle. AB is equal to 12, BC is equal to 4, CD is equal to 3, and AD is equal to 13. What is the area of quadrilateral ABCD? So if a shape is convex, that means that one of the angles, one of the interior angles, so in this case it would be this angle here, is greater than 180 degrees. So it looks like it kind of caves in on itself, so that's why it's called concave. Or non-convex, yeah. Because basically convex and concave are opposites. Okay, so let's start. So the first thing we can try to do is connect BD. And we'll notice that if we do that, since we're given that this is a right angle, that means that BCD, by the Pythagorean theorem, BD must be 5. And we'll notice that in triangle ABD now, we have the lengths of 5, 12, and 13. And 5, 12, and 13 make a right triangle again, because it's a Pythagorean triple. So here's a right angle here. And they're asking us for the area of ABCD. So ABCD, these brackets here mean area. So ABCD is equal to the area of ABD minus the area of BCD. And ABD is equal to 1/2 times 5 times 12. And BCD is equal to 1/2 times 3 times 4. So this should give you 30 minus 6, which is equal to 24. So the answer is B. Okay, so it looks like we've reached 7 o'clock. So thank you guys all for coming. And next week, we'll probably be going over more geometry problems. And the questions we're going over next week are the same questions that I sent you in the previous PowerPoint or presentation, the 7/22 preview. So if you want to look at them ahead of time, you can watch that. Okay, thank you guys. Have a good week.